What is UK tech infrastructure? When people talk about technology in the UK, they usually mean consumer-facing products, apps, platforms, startups, or devices. In reality, most of the technology that shapes daily life in the UK operates beneath the surface. It is embedded into essential services, regulated industries, and public institutions. It is not designed to be visible, and it is not designed to change quickly. UK tech infrastructure refers to the underlying systems that allow digital services to operate reliably across the country. It includes physical networks, data centers, compute platforms, identity systems, payment rails, public sector platforms, regulatory mechanisms, and operational processes. It is not owned by a single entity, and it was not designed as a single system. It has evolved over decades through policy decisions, commercial incentives, and operational necessity. Understanding UK tech infrastructure requires looking at how these layers interact, where responsibility sits, and why certain decisions are made conservatively rather than optimized for speed. Fixed connectivity and access networks. Fixed connectivity forms the base layer of digital infrastructure. Most homes and businesses in the UK connect to the internet through access lines owned by Openreach. Openreach is legally separate from BT Group's retail operations and is responsible for maintaining the physical network. Retail providers such as BT, Sky, TalkTalk, PlusNet, and others sell services over this shared infrastructure. This model is unusual outside Europe and has significant consequences. Investment decisions are made centrally while customer relationships are handled by retailers. Faults in the access network can affect multiple providers at once. Rollout priorities are shaped by national policy, regulatory targets, and cost modelling rather than individual consumer demand. Virgin Media O2 operates a separate cable network covering a large proportion of the population. Its network architecture differs from Openreach's fibre deployments and historically relied on hybrid fibre coax technology. This affects latency, performance characteristics, and upgrade paths. Alternative network providers such as CityFibre, GigaClear, HyperOptic, and Community Fibre build fibre in specific locations. Many focus on urban areas or new housing developments. Government programs such as Project Gigabit subsidise rollout in rural and hard-to-reach areas. These networks ultimately connect into core networks operated by large carriers and internet exchange points such as Linux, which handles a significant portion of UK internet traffic. Mobile networks and shared infrastructure. Mobile infrastructure is similarly layered. The UK has 4 major mobile network operators: EE, Vodafone, O2, and 3. Each operates radio access networks, spectrum holdings, and core network infrastructure. However, network sharing agreements are common. For example, EE and 3 share certain infrastructure, as do Vodafone and O2 through joint ventures. Mobile virtual network operators such as giffgaff, Tesco Mobile, and Sky Mobile rely entirely on underlying networks. This creates additional layers of dependency. Mobile networks also depend heavily on fixed infrastructure. Base stations require fibre backhaul. Core network components are hosted in data centres. Signalling systems interconnect with international networks. Coverage obligations are enforced by Ofcom, and spectrum auctions shape long-term network capabilities. Infrastructure decisions are therefore tightly coupled to regulatory frameworks. Subsea cables and international routing. UK tech infrastructure is deeply dependent on international connectivity. Dozens of subsea cables land in the UK, connecting it to the United States, continental Europe, and beyond. Major landing points include Cornwall, Kent, Suffolk, and the North East. These cables carry financial transactions, cloud traffic, voice communications, and content delivery. London acts as one of the world's major internet exchange hubs. Traffic between international networks is routed through facilities such as Telehouse, Equinix, and Digital Realty campuses. Because of this role, subsea cable infrastructure is treated as strategically important. Cable routes, landing stations, and associated facilities are monitored and protected. Physical damage, whether accidental or deliberate, can have immediate national impact. Data centers as critical national assets. Data centers form the physical backbone of digital services. The UK hosts thousands of data centers, ranging from small enterprise facilities to hyperscale campuses operated by cloud providers. Key concentrations exist around Slough, West London, Docklands, and the M4 corridor. A hyperscale data center may consume tens of megawatts of power, require multiple grid connections, and maintain on-site diesel or gas generation. Cooling systems are engineered to handle constant heat loads, and physical security is comparable to that of industrial sites. Many data centers host systems designated as critical national infrastructure. These include banking platforms, payment systems, healthcare services, emergency response systems, and government platforms. Planning approval for new data centers increasingly involves central government, local authorities, and energy regulators due to power demand and grid constraints. Cloud platforms and supplier concentration. Cloud computing has become a central dependency. Amazon Web Services operates multiple UK availability zones primarily in the London region. Microsoft Azure operates UK South and UK West regions. Google Cloud operates a London region. These platforms host workloads for banks, retailers, NHS trusts, local authorities, and central government departments. Cloud platforms provide infrastructure services, platform services, and increasingly software services. They manage identity, encryption, monitoring, logging, and scaling. This concentration creates efficiency but also systemic risk. A major outage or vulnerability in a widely used cloud service can affect large portions of the economy simultaneously. As a result, government guidance increasingly addresses supplier concentration, exit strategies, and operational resilience. Legacy systems and technical debt. A significant portion of UK infrastructure runs on legacy systems, core banking platforms, benefit systems, tax processing engines, and industrial control systems often run on mainframes or older programming environments. These systems persist because they are stable, well-tested, and deeply integrated into organizational processes. Replacing them involves high risk. Data migration, parallel operation, legal compliance, and operational continuity all complicate change. Many modern services are built as layers on top of legacy platforms rather than replacements. Technical debt is therefore an accepted feature of infrastructure managed through controls rather than eliminated. Digital identity and verification. Identity is a foundational infrastructure layer. In the public sector, gov.uk1 login aims to provide a consistent identity experience across government services. It replaces a fragmented landscape of department-specific login systems. Identity verification relies on document checks, biometric matching, and data sources such as passport and driving license records. Assurance levels are defined by policy rather than convenience. In the private sector, banks and regulated firms operate identity processes to meet anti-money laundering and know your customer requirements. These processes integrate with credit reference agencies, document verification providers, and internal risk systems. Identity failures can lead to fraud, exclusion, or regulatory breaches, which is why identity systems are conservative by design. Payments infrastructure in detail. Payments infrastructure is industrial scale. Faster Payments processes millions of transactions daily. Bax processes salaries, pensions, and benefits. CHAPS handles high-value wholesale transfers used by financial institutions and large corporates. These systems are operated by Pay.UK under oversight from the Bank of England. Settlement occurs through accounts held at the central bank. Availability requirements are extremely high. In addition to domestic systems, the UK integrates with international payment networks, card schemes, and clearing systems. Resilience and fraud prevention are continuous operational concerns. Public sector digital platforms. Central government operates shared digital platforms. gov.uk provides a single interface for citizens. Behind it sit services such as gov.uk Notify, gov.uk Pay, and shared analytics platforms. These services are reused across departments and agencies. Departments such as HMRC operate some of the largest transaction processing systems in the country, handling tax collection, customs processing, and compliance. Local authorities integrate with central platforms while maintaining their own systems for housing, planning, social care, and education. Health infrastructure. The NHS runs one of the most complex digital ecosystems in Europe. Systems such as the NHS Spine provide national services including patient identity, prescription services, and messaging. Local trusts operate clinical systems from vendors such as Cerner, Epic, and SystemC. Interoperability between systems is a constant challenge. Data sharing must balance clinical need, privacy law, and operational reality. Failures in healthcare infrastructure can directly affect patient safety, which heavily constrains change. Education and research networks. Education infrastructure includes national research and education networks such as JANET, which connects universities, research institutions, and schools. These networks support high bandwidth research, data sharing, and collaboration. They operate separately from commercial internet infrastructure and have specific performance and security requirements. Transport and industrial systems. Transport relies on digital infrastructure. Network Rail operates signaling and control systems that manage rail traffic. Aviation relies on NATS systems for air traffic control. Ports and logistics hubs use digital platforms to manage cargo and customs. Many of these systems combine modern digital interfaces with legacy control technology. Security and safety requirements dominate design decisions. Cybersecurity coordination. Cybersecurity is treated as a systemic concern. The National Cybersecurity Center coordinates response to major incidents. It issues guidance, threat intelligence, and mitigation advice. Large incidents often involve coordination across government, industry, and international partners. Security is embedded into infrastructure operations rather than treated as a feature. Regulation, standards, and procurement. Regulators such as Ofcom, the FCA, and the ICO shape infrastructure indirectly. Standards, bodies define interoperability requirements. Procurement frameworks determine which technologies are adopted and for how long. Procurement decisions often lock infrastructure choices in place for a decade or more. Why infrastructure is cautious? Infrastructure supports essential services. Failures affect millions. As a result, change is slow, deliberate, and heavily tested. Stability is prioritized over novelty. Closing. UK tech infrastructure is not exciting by design. It exists to support society quietly and reliably. It reflects decades of decisions about regulation, risk, and public service. Understanding it explains why the UK's digital systems behave the way they do, and why infrastructure is treated as a public good rather than a product.